Hello. So the next practice problem where we have to look at the reaction mechanism and determine the rate law is a little different because the second step is the slow step. And that will often cause us a little bit more difficulty because that often means that there's an intermediate in it. So we just need to be careful and keep track of, well, it's tricky. So write the equation for the overall reaction, pretty straightforward. I notice that the N2O2 is the intermediate. So it looks like the overall reaction is 2NO plus Br2 yields 2NOBr. It's balanced, so it looks good. Now, if we go to writing the rate law for the reaction, the first step is just the same as always. The slow step is the rate determining step. So rate equals K, and then I look at the slow step and just write the rate law as you normally would. The concentration of N2O2 times the concentration of Br2. But we can make this better by substituting in for the intermediate. Because we can never measure the concentration of the intermediate, it's not something that we would add, that we would start with, this is not going to really be useful at all. If I look at the first reaction and see how it's at fast equilibrium, we haven't really looked at equilibrium much. That's something that we would have done a teensy bit of in first year chem, but what equilibrium means, it means that the rate of the forward reaction would be equal to the rate of the reverse reaction. Look at the rate law for the forward reaction and write that down. The rate law of the forward reaction would be, K times the concentration of NO squared, and that would be equal to another K times the concentration of N2O2. And these Ks, they're numbers. They differ depending on temperature, which this question doesn't give us. So we just know that they are going to act as an actual numerical value, and then all get jumbled up into the final K at the end. What I can do here is substitute. Instead of writing N2O2, the concentration of N2O2, because it's an intermediate, I don't want to have that in there, I can substitute it for what I figured out it was equal to according to the first reaction. I could write, because the first reaction was at equilibrium, I could write this equation. And now what I can do is substitute in, all these K's are coming together, so they're not all representing the same number. But instead of writing N2O2, I can write the concentration of NO squared times the concentration of Br2. I'm just substituting in, since I found that NO2 squared is equal to N2O2, I'm substituting that in, and that makes more sense since that is a reactant. This only happens under one very specific circumstance, when the first step is fast equilibrium and the second step is the slow step. Few practice problems with this. It says, let's consider the hypothetical reaction 2C plus D yields J plus 2K. You are told that the rate of the reaction is second order overall and second order in C. Well, if it's second order overall and it's second order with respect to C, then that means that's all that it is. It must be, rate equals K times the concentration of C squared. Could any of the following be a rate determining first step in a reaction mechanism that is consistent with the observed rate law? So you just need to go and look and do any of these match the observed rate law? And yeah, A does. Because C, right, coefficients become exponents. Another way to write this would be 2C, right? Practice exercise 2 Ozone, this is another mechanism for ozone reacting here. Ozone reacts with nitrogen dioxide to produce dinitrogen pentoxide and oxygen. The reaction is believed to occur in 2 steps. The experimental rate law is K times the concentration of O3 times the concentration of NO2. What can you say about the relative rates of these? So notice it doesn't tell us which one is slow and which one is fast. But if this is the observed rate law, then that must mean that that first reaction was the slow step and thus the rate determining step. So what can you say about the relative rates? You could say that the first one is slower than the second one.